6 is a review of complex numbers. Okay, so it's really everything in this lesson, it's anything and everything that has to do with I, which is standing for our imaginary unit. Okay, the imaginary number. What do we remember about I?
It's imaginary.
Yeah, what's it equal to?
-1.
Not just -1.
Plus or minus.
No.
-1. Square root of -1.
There we go.
I thought if there were two eyes, this was just one.
Okay, but I'm not two I's. And it's not just one then. Okay, so I itself, the definition of I, the imaginary unit, is the square root of -1. If we can't do, if we're just working in real numbers, when we come to the square root of a negative, we just say we can't do it. We say it's not a real number. If we're working with our complex number system, we can do it. So I is the square root of -1. What does that mean I squared is? When you square square roots, just -1. So I squared is -1. And we talk about complex numbers. Complex numbers are any numbers that are in the form of a plus bi. Okay? So when I refer complex numbers, what I'm saying essentially is a plus bi. Okay? So we're doing some review. How do we work with them? Some of these are a piece of cake. Some of them get a bit ugly. So we're going to work with all this. So example 1, we're adding and subtracting complex numbers. So things like 7 minus 3i plus 4 plus 5i. Keep it basic. What do we do here?
7 plus 4.
Okay. 7 plus 4 is 11. And?
-3i plus 5i.
And -3i plus 5i is going to be?
2i.
So plus 2i. And what is 11 plus 2i?
11 with 2.
11 plus 2i. Okay. There was an example of an addition problem. What about B? Okay. 2 minus 8 is -6. What else?
-4.
Minus 4i, because you're doing minus I minus 3i. So that's like -1 minus 3, which is -4. And what is -6 minus 4i? The answer, -6 minus 4i. Okay, easy enough? Okay, well, we added, subtracted, let's multiply. How do we multiply 2 plus 3i times 5 minus I? We are foiling. So, 2 times 5. Two times minus I. Minus 2i. Okay, then 3i times 5. Plus 15i. 3i times -i.
-3i squared.
Minus 3i squared. Okay. Continue with this problem. Don't stop here. What do you see?
10 minus 13i.
Okay.
No, plus 13i.
10 stays 10. Minus 2i plus 15i is going to be a plus 13i.
Can you do -3 times a -1?
Does that sound familiar? What do we know about I squared? I squared is -1. So -3 times -1 is going to become a plus 3. Correct? So clean it up one more time.
13 plus 13i.
Yeah, 10 plus 3 is 13. So 13 plus 13i. Okay. Never leave an I squared in an answer. I squared can always simplify and become -1. So far, so good? Okay. Example 3. Raising a complex number to a power. So this time our complex number that we're working with is z, and z is defined to be 1/2 plus square root of 3 over 2 times I. We're being asked to find z squared and z cubed. Okay? Okay, I'm wondering if I left enough room here. This could be fun. Okay, so I'm going to start with z squared. How do we find z squared? 1/2 plus square root of 3 over 2 times I. And then officially, what is it?
-1.
Well, it's squared there, right? We're going to square that whole piece.
So 1/2 plus.
So then what's the better way to write it? In other words, if it's 1/2 plus square root of 3 over 2I, quantity squared, because we're trying to find z squared.
Just write the equation.
Yeah, so when we do z squared, then that means we're going to do then times another 1/2 plus square root of 3 over 2I. Binomial times binomial, so we're going to FOIL. Some foiling fun with these lovely little fractions. So, as we FOIL, 1/2 times 1/2.
2.
1 times 1 over 2 times 2. We're getting the mistakes out of the way now, right? Okay, outsides. 1/2 times square root of 3 over 2I. So 1 times square root of 3 over 2 times 2 times I. What's that going to make it? You got it. Square root of 3 over 4 and I. Then we're going to do the insides. Square root of 3 over 2I times 1/2. Square root of 3 over 4 times I. Who or what was that?
It sounded like a child.
It did. Oh no. Okay, and last. Square root of 3 over 2I times square root of 3 over 2I.
Square root of 9? No.
Yeah, square root of 3 times square root of 3. You can say square root of 9, or we can just 3. 2 times 2 is 4. I times I squared. Okay, did you stay with me through the first step?
Yes.
Now we've got several steps of cleanup to do. Okay, let's see. For the moment, I'm going to leave 1/4 as 1/4. We'll come back and deal with that later. Square root of 3 over 4I plus square root of 3 over 4I. What's that add to be?
3/4.
Square root of 6 over 8.
Oh, yeah.
No?
Square root of 6 over 4.
Closer. Square root of 3 plus square root of 3. When we have radicals, we don't add the insides. They have to be like radicals. And think of this as 1 square root of 3 over 4 plus 1 square root of 3 over 4. And that is going to make it 2 square root of 3 over 4 times I. Does that make sense? 2 square root of 3 over 4 times I. So the 4 is the common denominator, so we're keeping the 4. An I term plus an I term is going to be another I term. And then basically, 1 square root of 3 plus 1 square root of 3 is 2 square root of 3. Or you can think of it as 1/4 plus 1/4 is 2/4. Okay, we'll clean that up again here in a moment. What do you know about 3/4 I squared?
-3.
Right? I squared is -1, so plus 3/4 I squared becomes minus 3/4. Okay? 2 bits of cleanup, and then I'll be happy.
-1/4 plus -3/4.
Okay. And what is 1/4 minus 3/4?
-1/2.
Okay. -2/4, which becomes -1/2. Plus, what about this 2 square root of 3 over 4 times I? What do you know about 2/4? It's a half, right? So think of this as 1 square root of 3 over 2, or if you will, just square root of 3 over 2 times I. And you could say 1 square root of 3 over 2 times I if you'd want, but the 1 is unnecessary. So z squared turns out to be -1/2 plus 3. -1/2 plus square root of 3 over 2 times I. Did you follow all the pieces there? Notice I've slowed down a little bit. I'm not going to take these as fast because I've got it to make sure we know what we're doing here. Now, am I done with here? No. Now we've got to do z cubed. What would be the smart move here to do z cubed?
Just take that.
Throw it in. Just take that and then multiply that by.
Yeah. And I assume when you guys are saying take that, we're talking about z squared, yes?
Yes.
So take the z squared we just got and multiply it by z. That's going to be your smart move. That's going to save you a little bit of work here. So z squared turned out to be -1/2 plus square root of 3 over 2 times I times the original z, which was +1/2 plus square root of 3 over 2 times I. And FOIL? You'll see a lot of similarities, but there's a big difference also. So first, -1/2 times +1/2?
-1/4.
-1/4. Okay, outsides. -1/2 times square root of 3 over 2I. So 1 times square root of 3, 2 times 2, and an I, and it was a negative times a positive, so negative square root of 3 over 4 times I. Insides. Square root of 3 over 2I times 1/2 is going to be plus square root of 3 over 4 times I. And last, square root of 3 over 2I times square root of 3 over 2I is going to become what? Plus 3/4 I squared. Okay. Clean up.
The middle cancels.
Did you guys catch that? Negative square root of 3 over 4I plus square root of 3 over 4I. Those are gone, right? So, what's that leave me doing? -1/4. It was plus 3/4 I squared. I squared becomes -1, so it's minus 3/4. And what is -1/4 minus 3/4?
-4/4.
Okay. -4/4, which is equal to -1. Now, as I turn and look at my notes, okay, if you see specifically in the directions to write your answer in the form of a complex number, okay, remember a complex number is the form a plus bi. All of our other answers up until now have been a real term plus an I term, yes? A plus BI, A plus BI. How could I write this one as A plus BI? It's -1 plus what?
1 I.
Not 1 I.
I.
No. 0 I. In other words, because there is no imaginary part here, right? So basically, if you have a real number like -1 and you're asked to write it in a complex number form, it's -1 plus 0 I. Okay? Okay, let's try the bottom half then. Oh, we're going to be diving complex numbers. Okay, ready to do some diving? Guess that's a different form of dividing.
Oh.
You didn't even read it that way, did you?
I thought we were legitimately doing something new called diving.
Nope.
Okay, that's fine.
No, that is a typo on my part. It should say dividing. Okay, 2 divided by 3 minus I. Okay.
Multiplied by the negative.
Not exactly negatives,
Reciprocal.
not reciprocal.
Just multiply by itself.
Not exactly. We want kind of a happy medium between itself versus the negatives. So
3 minus I, 2.
Is it
That's-
3 plus I?
there we go.
Okay.
Okay, so we're looking at the denominator. And if you guys recall, the rule is we're not allowed to leave a square root in the denominator. That means we're not allowed to leave an I in the denominator. So to get rid of that I when it's part of a, in this case, a difference, we're going to multiply by the conjugate. The conjugate of 3 minus I is 3 plus I. Generally, it's just changing that middle sign when we talk about conjugate. So we're going to multiply by 3 plus I. What I do in the denominator, we're going to do in the numerator. And then we multiply. How do I multiply on top? You just distribute. 2 times 3 plus I is going to become 6 plus 2I. How do I multiply 3 minus I times 3 plus I? Distribute. We can talk FOIL. Okay, so 3 times 3 is 9. 3 times I is plus 3I. Minus I times 3 is minus 3I. And minus I times positive I is minus I squared. Okay? What happens? Okay. In true fashion, we are multiplying by the conjugate. The whole point of multiplying by the conjugate is we get the middle terms to cancel. So, what do you know about minus I squared? Yeah, it's going to be minus -1, which is plus 1. So, on top, I still have 6 plus 2I. Denominator, 10, because it's 9 minus -1, which is 10. Am I done? Okay, I agree. We're not done. What do you think?
Can the 6 and the 10 say?
The 6 and the 10, did you say?
Yes.
Has to be more than just 6 and 10. Has to be 6, the 10, and the 2. They are all 3, so all terms have to be able to divide by the same number. In this case, they can all divide by 2. So when we divide all of those pieces by 2, I'm going to come up with 3 plus I over 5, which, if we're going to get nitpicky here and write it in the form of a complex number,
3 plus 0I.
no.
No.
The idea is instead of having one fraction, this is 3 over 5 plus also, you can say I over 5. Or if you prefer, you can say 1/5 I. Okay? But the idea is when we talk specifically complex number, it's officially taking it and breaking it into a real plus a complex part.
Stop with my desk, yeah.
You just what?
My desk started going back.
Well, I'm glad you managed to
I got her.
bring it back. The first time I sat down on one of these desks, I just like slid into it real fast and I started to tip backwards. I was like, oh
That's
no.
the first time I've ever tipped one of these. So.
I was like, oh no, this is not a good scene for a group of high school students. Thankfully, you're high school, not middle school. I'm not sure. Middle school could be bad, I think, one of these.
Oh.
Okay. You're awake now, right?
Yeah.
Okay. B. What are we doing on B?
5 by 2 plus 9.
Okay, got it. Conjugate of the denominator, so conjugate of 2 minus 3i is 2 plus 3i. What I do to the denominator, I'm doing to the numerator. So, on top, difference this time is on top and on bottom we have to FOIL. So, FOIL away. 5 times 2, 10 plus 15i plus 2i plus 3i squared. Denominator, 4 plus 6i minus 6i minus 9i squared. Sorry, I hope you're not disappointed in me. I did the foiling for you. Okay, what do you see on top? Okay, 15 and 2i are going to add together and become 17i. Plus 3i squared is the same thing as minus 3. So 10 minus 3 can go together. So we have 7 plus 17i. Okay, denominator. 6. Okay. As conjugates should, the middle terms cancel, so 6i's cancel. Minus 9i squared becomes plus 9. And 4 plus 9 is 13. So if I write this in true complex number form, 7/13 plus 17i over 13, or 17/13i. Okay. In all honesty, if you ask me, we've gotten past the hardest stuff. My opinion would be the hardest stuff was back there doing the z squared to the z cubed. Just because they threw in fractions and, fractions, radicals, i's, everything all at once. Okay, example 5. How do we solve x squared plus x plus 1 equals 0? I mean, the hint's kind of right there.
Quadratic formula.
Yeah. If you wanted to, you could start off asking yourself, can it factor? Are there two numbers that multiply to be 1 and add to be 1?
Yeah.
Unfortunately, you're not going to find any, you're not going to find that it factors. And so this is a quadratic formula problem. Quadratic formula, make sure your equation is equal to 0 to get me started. What are my ABCs here?
1, 1, 1.
Okay. A is 1, B is 1, C is 1. So let's do some quadratic formula. X equals negative B, so negative 1 plus or minus the square root of b squared, 1 squared minus 4 times a, which is 1, times c, which is 1, all over 2a, so 2 times 1. Negative 1 plus or minus, what ends up under my square root?
Negative 3.
Yeah. 1 squared is 1. 4 times 1 times 1 is 4. 1 minus 4 is negative 3. And this is all over 2. Now, we're not going to stop here, though. What about that square root? What about the square root of negative 3?
You have to pull out an imaginary number.
Yeah. So if you recall, simplifying perfect squares. Okay, 3 is not a perfect square, but there's a negative in there. So you can think of this as negative 1 times 3 under the radical, if you need a visual here. And the square root of negative 1 is I. So you end up with I times the square root of 3. So negative 1 plus or minus I times the square root of 3 all over 2. You could possibly leave it in that form. Or if they specifically asked you about complex number form, split into 2 fractions. Negative 1 over 2, which is negative 1/2, plus or minus. You could leave the I in front of the square root. That's what I was guessing. I would put it back. Or you can put it after the fraction. Say square root of 3 over 2 times I. That is officially your complex number form. Okay. I'm not saying that I would count this wrong. I would probably count this right too, I would think, unless there's some really strong reason I needed this. Okay. And one more. Okay. I think we did a teeny bit of this last year in Algebra 2. I don't really remember. But plotting complex numbers. The complex plane is just like the coordinate plane, where a plus bi is equivalent to the ordered pair a and b. So instead of having x-axis and y-axis here, what we have is we have a real axis. So this is your a-axis. And we have an imaginary axis. So in other words, your b-axis. The directions ask us to plot u, v, and u plus v in the complex plane. Well, if u is 1 plus 3i, what is that as an ordered pair? 1 comma 3. Okay, in other words, because it's a comma b. So it's the real number, which is 1, plus the imaginary coefficient, which is the 3. So in order to graph this, we're going to graph 1, 3. So I'm going to go where? Right one up 3. I'm going to call that u. V is 2 minus 1, or 2 minus I. What is that as an ordered pair?
2 negative 1.
Okay, 2 negative 1. So in order to graph 2 negative 1, we're going to go right 2 down 1, and that is your V. What about U plus V?
1 plus 2 and 3 plus negative
1. Yeah, you're putting your like terms together here, aren't we? You're taking 1 plus 3i plus the 2 minus I and putting it all together. So when we add like terms there, we're going to have 1 plus 2 is 3. 3i minus I is 2i. So 3 plus 2i, which is what is an ordered pair? 3, 2. So I'm going to go right 3, up 2, and that is the point for u plus v. Okay. Your homework's on page 51. Realize everything is evens. Okay? So 2 through 16, 26, 28, 34 through 38, 42, and 44. That homework is due tomorrow, and you have a few minutes work time? That's kind of crazy. I really thought these notes would take the whole time, but we got through them quicker than I normally do, I think.